I wanted to show an example of how to think about instantaneous rate of change when we can find the value of a function but we don't have any idea about its formula. So I'm imagining that I have a function f of t and it's measuring my position at time t. What I would like to find is the instantaneous velocity at a particular time, so here my time is at 1.42. Now the definition of the instantaneous rate of change, which is also called a derivative, is to calculate an average rate of change going between 2 points. So one of the times is 1.42. I don't know the second point of my interval, but I need to take a limit as that second point gets closer and closer to 1.42. So what I've done is I've created a table, and I've got some values for b, and notice that the values for b as my table proceeds are getting closer and closer to the time 1.42. And I want to calculate the average rate of change, so I have the value of my function at 1.42. I calculate that once, and then I'm going to use each of the values in my table, and I'll calculate the value of my function for each of those values. And the closer that I get to 1.42, the more decimal places I'm going to need. And I'll point out in a moment where that comes from. My average rate of change is the slope between my 2 points. So I'm going to calculate the value of my function at the second endpoint minus the value at the point I care about. And then I'll divide by the change in time. So it's the change in position over the change in time. And I calculate that. So I've set up the first several fractions that I'll be calculating. I've got my f of b minus my f of 1.42 divided by the change in my time. And so I'm just copying these values of f of b into the first spot. And I'm copying the value of my function, my position at time 1.42, and I'm putting that in the second spot. And let me point out now why I want to be including more decimal places. So notice that for my later times, my value of position is getting closer and closer to 6.0776. So here I am at 1.4201. 6.0776 is not very far away. If I subtracted and I only kept these first couple decimal places, I'm going to lose a lot of accuracy when I do the subtraction. I've canceled a lot of digits. And notice here, 1.42001, I've lost even more decimal places. So I'm just going to keep track of more of those values. Now, I'm going to go in and I'm going to calculate with a calculator the value of these fractions. And because I'm now on the iPad instead of the board, I'm going to write those values into the table. So give me just a moment. Alright, so I've gone and used my calculator and I've calculated these values. And so this first ratio, I get negative 18.92. My second value, negative 18.6 exactly. Then negative 18.456. And then negative 18.4416. And I didn't write down the fraction on this next one, but when I calculate, negative 18.44016. Oops, 16. There we go. So if I look at these values, I can see that they are steadily getting closer. Like negative 18 is fairly consistent for all of them. But my decimal values are settling in at 4416 and 016. I would approximate that it looks like it's getting close to something like negative 18.44 something. And WebWork, for example, typically only looks for 4 or 5 digits of accuracy. And it really does look like this limit is getting very, very close to negative 18.44. And that's what I would put in as my answer.